Hi, dear friends. Welcome to this short tutorial on statics of solid mechanics. My name is Gatogo, and in today's tutorial, I will take you through finding the gravitational force of attraction F between two bodies. Now, the law of universal gravitation states that any two bodies of any two particles of masses m1 and m2 separated by distance r attract each other by forces of magnitude F that is proportional to the product of the masses and inversely proportional to the square of the separation distance and acts along the line connecting the particles. Now we have a mass m1 and m2 separated by a distance r from their respective centers would attract each other by a force F. And mathematically, we're saying that this F equals to G times the mass of the first body times the mass of the second body all over the square of the separating distance between the two bodies. And this G is a universal gravitational constant, which is given to us to be 6.673 times 10 exponent negative 11 meter cube per kilogram dot second squared. Now let's take a look at this problem and try to solve it. Now the question reads, the 200 millimeter diameter spheres constructed of different metals are located in deep space. Determine the gravitational force F which the copper sphere exerts on the titanium sphere if A, d equals to 2.5 meters and B, d equals to 5 meters. Now these are the spheres given to us, copper and titanium, separated by distance d, and we are to find the gravitational force F if the separating distance d equals to 2.5 meters and 5 meters. Now in a question like this, we have to find what has been given to us, what we know about the question and what we are to determine. When you're able to determine these two things, then it will help you in solving your question. So we've been given two spheres of diameter each equals to 100 millimeter. That's from the question. And then we also been given separating distance d equals to 2.5 meters and d equals to 5 meters. Then what are we actually looking for? We're looking for gravitational force F, but we have just defined F to be the G, which is the universal gravitational constant, times the mass of the first body, in this case copper, and then the mass of the second body, which is titanium, in this case, all over the separating distance squared. And then our separating distance is here given d. So we also know our universal gravitational constant to be 6.673 times 10 exponent negative 11 meter cube per kilogram dot second squared. Now what do we not know? We don't know the mass of copper and then the mass of titanium. So we have to calculate the mass of both copper and titanium. Now we know mass to be rho v, and that's the density times volume. Mass equals to density times volume. And then the density of copper, we know it to be 8.96 times 10 exponent 3 kilogram per cubic meter. And then the volume of copper sphere is also given by 4/3 times pi times the radius of copper cube. And then the radius of copper, which is the RC, we don't know, but we know the diameter of copper sphere to be 100 millimeter, which is given to us in the question. So to get the radius, you divide 100 millimeters by 2 to get 50 millimeters, and then you convert to meters because you are dealing in SI units. When you convert 50 millimeters to meters, then you get 0.050 meters. Then you now put in the values of the density and then the volume. So 8.96 times 10 exponent 3 kilogram per meter cube for the density of copper times the volume 4 over 3 times pi times the radius cube, which is 0.05 meter cube, will give you the mass of the copper. And when you're able to punch your calculator well, you will arrive at 4.6914 kilogram to be the mass of the copper. Now you do the same thing for the mass of titanium. You know the mass of titanium to be the density of titanium times the volume of titanium. So the density of titanium, we know it to be 4.5 times 10 exponent 3 kilogram per cubic meter. And then the volume of titanium sphere is also given by 4 over 3 times pi times the radius of titanium cube. The radius of titanium sphere we don't know, but we know the diameter of titanium sphere, which has been given to us in the question, to be 100 millimeters. So to get the radius of titanium, you just divide by 2, and then you get 50 millimeters, and you convert to meters to get 0.05 meters. Then you slot in the values of the density of titanium and then the volume of titanium. The density is 4.5 times 10 exponent 3, and then the volume is this whole expression 4 over 3 times pi times 0.050 cube. Then when you're able to punch your calculator well, you should get 2.3562 kilogram, and that gives you the mass of titanium. Now that we know all the parameters, we can now substitute the values into the gravitational force formula, which we know to be G over M over the mass of the first body times the mass of the second body, all over the square of the separating distance. And so we know the universal gravitational constant to be 6.673 times 10 exponent negative 11, and then we know the mass of copper to be 4.6914 kilogram, and then we also know the mass of titanium to be 2.3562 kilogram, all over the separating distance 2.5. In this case, we have to calculate the force F when the separating distance is 2.5 meters. So you slot in that value of D, which is the separating distance, 2.5 meters squared. And when you punch your calculator well, you should get 1.1802 times 10 exponent negative 10 Newton. Then the second part of the question is asking us to calculate the force when the separating distance D equals to 5 meters. Now you slot in the values of G, which you know to be 6.673 times 10 exponent negative 11, the mass of copper 4.6914 times the mass of titanium 2.3562, all over the separating distance squared, which is 5 squared. Then when you punch your calculator well, you should get 2.9505 times 10 exponent negative 11 Newton. And that gives you the force, the gravitational force when the separating distance between copper sphere and then titanium sphere is 5 meters. And that is how to calculate for the gravitational force of attraction between two bodies. Thank you.